Morning, ladies and gentlemen. We are going to do an AP type test question.
This is a multiple choice question for an AP test a few years ago.
A satellite of mass m and sleep.
We all wish.
Speed v moves in a stable circular orbit around the planet of mass m. What is the radius of the satellite's orbit?
Might want to look through your notes to see what the heck we're talking about here. This was from yesterday. So on your mark, get set, go. Pause this and figure it out. A, B, C, or D, or E.
Okay, so you should have found something in your notes that looks like this.
Yep.
And we are asking for the radius, and so that's
By the
easy.
way, on the left we have the centripetal force.
Oh yeah.
And on the right we have the force of gravity.
So centripetal force equals the force of gravity. That's what we start with. We break it down. For mass times acceleration. This is acceleration.
Yep.
And then this is just what it is. Newton's laws of gravitational.
So the mass of the satellite goes away.
Yeah, these disappear, and then this cancels this one out. And we're trying to find the radius, right?
Yep.
So can't we just blank and flip this?
Yep.
Yeah. All right. Sweet.
Boom, boom.
the
So that was
answer-
letter C.
C. Okay, moving on. What is your... Oh, pause. Not pause. Too excited. Okay, so...
Grab a book wherever you are.
Yes, pause the video, grab a book for me, and start with it by your side, like this.
Hold it down at your side, yeah.
And I want you to move it slowly up. Stop right... Oh, there. And then... Oh, keep going. Much better, okay.
And the question is...
What is your shoulder experiencing? And why?
Take it all the way down and stop right there.
The burn! And we keep going.
As that angle changes, what do you feel in your shoulder?
It hurts. But why?
Yeah, but it doesn't hurt everywhere, and it
doesn't
hurts
hurt
worse.
everywhere. It hurts the most when it's out here.
Yeah.
Right? So let me go ahead and use my plumb bob to show you guys what's going on here.
So you can see when it's above your head, no pain.
No
Down
pain.
when it's by your side, no pain. But here in this zone,
This is the
that's
red
where
zone.
the pain resides. ¿Por qué? ¿Por qué no?
Okay, so let's go ahead and take a look at this. So this is a plumb bob, and it is going
The
to
plumb
show...
bob shows the direction of the force of gravity acting on the book.
And so I just should go straight up first, and I'll add the ruler in later, right?
Sure,
The
yeah.
meter stick? Okay. So as I move the book up, the plumb bob points the direction of the
Force of gravity is always out. Look at that angle between the string and her arm. Okay, keep going up. What happens to that angle of the string
It's
where
right.
the pain is less? Less
Okay.
angle,
Less angle, less pain.
More angle.
Red zone, red zone.
More pain. And then on the way down, what's happening to the angle here?
Okay, well, it's obviously really big.
Look at
but-
the angle between the book and the string.
Over
That's
here.
kind of like at the top. I hadn't noticed that before. All right, so what's going on?
So, well, I'm gonna add in that meter stick in a second, but we'll
Yeah,
go to my
well-
next slide here. The reason for the season, the reason for this is the torque, which is a twisting force.
And the symbol for torque is the Greek letter tau. That's the Greek letter tau.
It looks like a T, it's helpful.
Yeah. And that's what you were feeling on your shoulder. Your shoulder was being twisted.
So, the axis of rotation, or the fulcrum,
What was it when you were holding the book?
is my shoulder, in
All
this
right.
case.
So that's the first. There are three important parts here. What's going on? The first is the axis of rotation.
Axis of rotation, and like we said, that was our shoulder. And the next thing we want to talk about is our line of action, which is an extended line, which is really important. This one only shows half of it.
Yeah.
It actually continues going up all the way. Extended line drawn collinear with the force.
So we had the force of gravity that was down, that was indicated by that, and it's always down, regardless of where you have your arm. That force is always down. And the word collinear, I mean, if you take it up towards your shoulder, you can see the force is down. But collinear means imagine the string extending both down and above her hand. We'll get to that here in a minute.
Okay. So this is like my hand, right? I'm sorry, about like my arm.
Your
right here,
arm, right.
Okay, this is my little plumb bob thing.
Yeah.
And
The real thing is in the next slide, though. That's the lever arm. This
yeah. This is what we want. Okay, so the lever arm.
And write this down. This should definitely go in your notes.
This is important. This is hard. It's hard to visualize. So we'll show you.
It's alien. They have no
Yeah.
experience with it.
Level arm, distance between the line of action. That's this thing that
Yeah.
goes here and up.
The plumb bob.
The plumb bob. And the axis on a line perpendicular to both.
So the two dotted lines there are perpendicular to each other. Like the brown thing there is your arm, your actual arm, and that perpendicular distance is called the lever arm. And the arrow there shows the force. Let's go to the...
Let's show them.
Yeah.
Okay. So, here we go. So this is my lever arm. This, not my arm,
Here.
this.
Yeah.
Okay, I'm gonna put it right here. And you know what I'm gonna do? I'm gonna start with it up top.
I like that.
Yeah. So this is my lever arm right here.
Yeah.
And notice where my plumb bob falls. It's a short distance, right?
Yeah. So the plumb bob, the string is the line of action, and the lever arm is the distance from the shoulder to where the string is. Now, as you bring it down, what happens to the lever arm? It gets longer. That's where the string is touching the meter stick, gets longer and longer until it's maximum out where, ow, 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 ow. Now take it back up where it doesn't hurt. Notice the lever arm gets shorter. Where the string touches the meter stick gets shorter and shorter and shorter until you hold it straight up.
And what's the angle between the lever arm and the line of axis always?
Perpendicular. Now the line of action is the string, and the lever arm is the meter stick. Notice her arm is her arm, but the lever arm is where the string touches the meter stick.
Okay, I'm getting hard. Okay, what happens when I go down here though?
Well, you have to extend. If you visualize, stop right there. If you visualize the string going back up, you can see that that lever arm gets shorter. Go ahead and take it down. And so
this is really
the
hitting
lever
it.
arm
Like,
gets
really?
shorter and shorter. You can't do it. There's no way. I was using my finger.
Yeah.
So
Oh, you are good. Okay,
yeah,
good.
so if you extend that line up, okay, the lever arm gets longer and longer
Sweating.
on the other side. There you go. Feel the burn.
Do you see me shaking?
Yeah.
I can feel it.
Yeah. And the lever arm gets shorter and shorter, and the pain goes away.
at
Why
that.
is that?
Why?
So there's three different things. There's the axis of rotation, there's the line of action, and there's the lever arm. And they're not hard concepts. You just have no experience with them.
Yeah, you just need a little practice, right?
That's right.
Okay, so here is the relationship between torque, that twisting force, and the lever arm.
Yep.
Right. So torque equals the force times the lever arm. It's very short.
It's a simple thing. It's a simple thing.
Yeah. So as long as you know the force and you know the
Let's
distance
go
of the
over
lever
towards
arm.
the door and show them that.
Door demo. Okay. Door demo. All right. So.
I think you should push on the window there.
The window. Okay.
Okay,
So
the-
I'm gonna
the
push,
hinge is the axis of rotation. The hinge is right there.
and I'm gonna push right here where it's 0.8 meters.
Okay.
Right there. Okay, and I am going to push it with 100 newtons. Wait, I do need to open a little bit though. With 100 newtons, perpendicular right here. Ready?
So it's perpendicular, so 100 newtons, and that causes the door to twist because it's exerting a force on it.
Look at my finger. Ew. Okay.
All right, so how much is that according to our...
So torque is force times the lever arm, and force is 100 newtons. My lever arm is 0.8. Isn't that just gonna be 80?
That's going to be 80, and what are the units going to be?
Well, force is newtons. Newton
What?
meters?
Newton meters, yep.
Yeah. Okay.
It's a Newton meter. Now that is not the same as a joule.
No, different.
It's not energy here, it's torque.
So what if I change the angle?
How could you do that?
So instead of pushing perpendicular with the lever and my force,
Yeah.
now I'm pointing at an angle
Oh,
like this. So this means
yeah, go ahead. No, I got it.
that I now need to look right here for my lever arm, right?
Yep.
right? Okay, because this is where it's perpendicular.
Yep.
Okay, so again, it's 0.8 meters here. But I'm gonna go and push. This is 45 degrees.
Let's call it 45
Yeah.
degrees. I like
And here
that.
we go.
I noticed that it's harder to push.
It's totally harder.
All right, let's go see why.
Okay. So let's draw this out. Where is my, maybe we'll use purple. Okay, so here is the door.
Yep.
And here is my finger pushing with 100 newtons, we said, at a 45.
And the door was 0.8 meters.
0.8 meters long.
And
Okay.
put an X for the axis of rotation.
Oh, thank you. Right there. Boom. Okay, because that's where the hinge was, right?
Yep.
And we know that the definition of our lever arm is the distance between the line of action, which is this, what I'm pushing,
Yeah.
and the line of action and the axis, and the distance between the line of action and the axis on a line perpendicular to both.
Make a dotted line. No. Make a dotted line on that 100 newtons behind and
Oh,
in
thank
front.
you, right here.
So dotted line goes that way.
So here is our axis.
And dotted line goes that way. And where, if you draw a line from the axis of rotation down to there, where would it be perpendicular?
Well, it's gonna be perpendicular when it hits right here.
No, that's not perpendicular.
Right? Is it not? Maybe right there?
Right there, yeah.
Details.
Yeah. Well, no, it's important.
Yes, it is.
See, now that's 90 degrees.
Okay.
Okay, so label the lever arm with an L.
And can we figure this out? Can we find out?
Well, if that's like a triangle, hypotenuse is 0.8. We've got an angle of 45 degrees. What side is the lever arm there?
This is the opposite side,
Opposite
right?
side, yeah.
So we can just say point.
Mr. Boykin made a mistake earlier.
Yeah, I was like, I was the first time before. So we've got 0.8 times the sine of 45, and that's gonna give me my lever arm. Okay, so 0.8 times the sine of 45, and I get 0.5, we'll call it 0.6.
0.6 meters. So the lever arm is 0.6 meters. So, and the
Okay.
force was 100 meters, so now the torque is
Well, what, 100 times 0.6, that's just gonna be
60.
60
Newton meters.
meters. Boom.
Is the torque. By the way, you're using, okay, yeah, that's torque.
Wait, what, wait.
Well,
Do you need to make it look like this?
here.
How
Yeah,
do you do it, Boykin?
I do it like,
The expert. Oh, snappers! Okay. This is how you learn how to write in middle school when you're a kid, right? Okay, that's what it's gonna be. You saw it here first.
all right, torque.
Okay, torque.
The Greek letter tau.
Did we want to do one more with it smaller?
Well,
It was
if you make that angle smaller, it's going to be impossible to open the door.
Right? If I made this like 15 degrees, if I was like,
Let's go show them. And I'm going
Okay.
to go up. So
Ready?
if you're pushing that, it's hardly any of the force is going towards opening the door.
my finger.
Most of the force is trying to make the door move away from the hinge. So that's not going to work.
Okay. Moving along. We did this already. If you don't have it written down, write it down.
Yeah.
Did we have another homework number that we're gonna put in there? No, we were gonna do we were gonna put in those questions on Canvas. So you guys will go to Canvas and there will be some questions here for you that you will do. Plus we will have these pages, these ones.
Do
as well,
the
right?
do the Mayfield ones first. Do the Canvas questions first.
Yeah, those are a little bit easier. Start you off nice and easy.
And let's
then-
take a look at these problems though and give you a little explanation first.
Okay, so number 3 and number 5. Right here. And this is on page 243.
Yeah.
You are installing a new spark plug in your car.
Yep.
And the manual specifies that it be tightened to a torque that has a magnitude of 45 Newton meters.
Yeah.
Using the data in the drawing, determine the magnitude of F of the force that you must exert on the wrench.
So the first thing you got to do is find the length of the lever arm. Let me put my finger in there. And so that extends in this direction and this direction. And you're going to get a perpendicular somewhere over here, right? So make a sketch where you've got a perpendicular here. This angle is 50 degrees. Find the lever arm. And if what force What do they want? Yeah, what force will give you a torque of 45 newtons?
You guys can do that. Just algebra once you do your drawing.
Yeah.
And then number 5, it says, the drawing shows a jet engine suspended beneath the wing of an airplane.
Yep.
The weight W of the engine is 10,200 newtons and acts as shown in the drawing.
Yep.
Excellent. I hope so.
Yeah.
In flight, the engine produces a thrust of 62,300 newtons.
Yep. That
is parallel to the ground. The rotational axis in the drawing is perpendicular to the plane of the paper. With respect to the axis, find the magnitude of the torque due to A, the weight, and B, the thrust.
So once again, the idea is to find the lever arm, because you've got the force and you need the torque. You got to find the lever arm. The weight, the line of action goes down and it also goes up. Where are you going to get a perpendicular? Up here, right? So you got to find out what this is. Here's your hypotenuse. What's this? And then the force of the thrust is in this way. So the line of action goes this way and that way. And I think the lever arm is going to be right there. Can you guys figure it out?
That makes sense. That does. Okay. So start with the Canvas questions, the easy ones, and then I'll put the homework on there, and you'll do numbers 3 and number 5.
Sweet.